Alright, we will now continue with our RC circuit again. Just now we are talking about the charging. That means the capacitor was already fully charged to 20 volt. Now, if I were to remove away the power supply, the circuit now becomes like this. Okay, no more power supply. This is still my 4 kilo ohm, and here is 6 microfarad. Okay, and you recall my capacitor has already been charged to 20 volts. It was already 20 volts. Okay, 20 volts. 20 volts. Now the battery has already been removed. There's no more banker. Who is the banker now? The capacitor becomes a banker. Right? It's the energy that is being stored in the capacitor, now it's going to be released into the circuit. So now this is the capacitor that is fully charged. So the current now flow in this way now. If you remember, just now it was flowing this way. So now it's flowing this way. Right? And this is VC, and therefore this is now VR. Yeah? Okay? Now why do I draw my arrowhead opposite? Because my current is now flowing this way. Alright, okay, good. So let's talk about, eventually if you start with 20 volt, do you think you, just like your handphone, as your handphone is fully charged throughout the day, would the voltage drop eventually becomes 0 volt? It will, right? And then you charge it again at night, isn't it? So here is 20 volt to 0 volt. So VC is decreasing, right? So when VC is decreasing, your function is with bracket or without bracket? Of course it's without bracket, right? Yeah, so therefore in my example here will be 20 e minus t over 24 millisecond. If you still remember my time constant, R times C is 24 millisecond. Okay? Alright, how about VR? Now this, if you recall your EL tag, in your EL tag, if you have one battery, let's say if I say here is equal to 6 volt, what's the voltage here? It will be still 6 volt, right? 6, 6, 4, 4, 3, 3, 2, 2. So VR and VC is the same, because there is only one voltage source and one resistor. Okay? So VR is the same as VC. But we'll put down a minus sign here. Why do we put a minus sign? Because now my current is flowing this way. My current is flowing this way. And if I want my VR to be the same definition as my VR just now my VR was also this way, which is is opposite to my original current. Original current was flowing this way. Original current was flowing this way. So my VR was correct just now. So now if my VR is this way, but the current is changing direction, so my voltage should have a negative sign. Right? Should have a negative sign. And my current is therefore VR over R. So it's still minus 20 e minus t over time constant divided by my 4k. Alright, so that's called the discharging. So as you can see in the discharging, everything is decreasing. Everything is decreasing. So if I were to ask you to draw the graph for the charging, right? Charging, discharging, sorry. So we see discharging, so discharging. Alright? How about VR? It's also decreasing, but because I have a negative sign, so it's actually like this. Yeah. Right? And to draw the current of my the current, it is also a decreasing function, a negative sign, negative exponential expression. Okay? So what we learned is that in our discharging circuit, time constant formula is still the same, R times C. How long does it take for it to be completely discharged? Find time constant. And to write the mathematical expression is all decreasing function without the bracket. Alright? Okay, so with that, we are now ready to go on to using the very general expression to derive at all these equations, the exponential mathematical expression.